So let's talk about our bell work now that we were doing. This is actually 4.6, chapter 4.6. I ask you guys to find the next term in this series, and you were all able to do it. Isn't that right? What is the next term in the series? 16. And the next one? And the next one? 20. And then and 24. And I'm going to stop right there because wasn't that one the 10th number in the series? Okay. So you're able to find the next one. You know how to get the next one, and you can find the 10th one. But then I asked you to find the 100th number in this series, and things got a little iffy, didn't they? Yeah, they did. Okay. So what I'm going to teach you today is all the stuff you actually know, but you just don't know how to use it here. Okay? Because you know how to find the 100th term in this series. So first of all, looking at this series, what's happening every time? Okay. So we have what we call a common difference. And the common difference in this case is positive 2, isn't it? Okay. It makes sense to call it the common difference here. If we are graphing, we don't call it the common difference. What do we call it? Slope. That's right. We call it the slope. But it doesn't make sense to call it the slope here, does it? Okay. Now I want you to notice it's plus 2 every time. Okay? Plus 2, plus 2, plus 2. This is what we call an arithmetic sequence. Okay? So, sequence. And that means that there's a plus minus thing going on. It's either plus 2, plus 2, plus 2, or maybe it's minus 6, minus 6, minus 6. It's not, let me show you, it's not doing this kind of thing. You see what's going on here? You can see the pattern, can't you? What's happening? Times 2, right, Jack? Times 2. And you could tell me the next one, right? But this is not an arithmetic sequence. It's not the kind of thing that we've been looking at lately. We could also call it, well, we'll see here in a second. We've been learning about linear equations, right? Or linear functions. Well, this series, this arithmetic series, can be modeled with a linear equation. Okay? And what is that linear equation we use all the time for everything? We use point slope formula a lot. What's the other one we use? Yeah, y equals mx plus b. Where when we know the slope, we know the y-intercept, right? We got this. Okay. So what I'm going to show you is how we can make a model of this sequence, this series, using this type of function. So here's the first thing you got to understand. These are all called terms of the series. Okay, they're all called terms, that word. I used it up here, didn't I? Term. This is the first term, and the second term, and the third term, and the fourth term. Remember way up here, this was the 10th term, right? Okay. So that look kind of familiar? See what I've done here? So I turned the series into, from just a bunch of numbers in a series, I said, well, if that's the first term, then that's actually the point 110. This is the point 212, 314. What do you think happens when I graph the point 110, and then 212, and then 314? Say it louder. They line up. What's that word when they line up?
Linear.
Yeah, they're linear. These are linear points. And if they're linear points, there must be a linear equation that models what's happening. Do you agree? You're like, of course, Mr. Collard said it excitedly. It must be true, right, Nicole? Okay. All right. So, do you notice I left this little opening here?
Yeah.
Okay. There's a reason we left that opening there. What?
Zero.
Yeah, the zero. The zero term. Okay. So, in my function, when I put a 1 in, what comes out? 10. When I put a 2 in? When I put a 10 in? Okay. We need to know what comes out when we put in a 0. Well, what comes out?
8.
Yeah, you can see it. You can figure it out, can't you?
The y-intercept.
That is the y-intercept. Okay? That is the y-intercept. And so I think we can write a function. We could write y equal, do we know the slope or the common difference?
Yes. It's
2.
plus 2.
X. And do we know the y-intercept?
Yes.
Why did I put 0? There we go. Plus 8. Okay. So we have this function that models what's happening here. And if I want to know the 100th term in this series, yeah, I put 100 in for X. Now, I'm going to do something you might not like here, but we're talking about a series of numbers, and they're numbers, and we like to talk about the term, or the, we talk about the 10th term, we talked about the 100th term. We like to talk about a lot of times the nth term. What the heck do you think I mean by the nth term? Say it. Like, which one is it?
It's the first.
Yeah, it's whichever. Yeah, it's a variable. It's whichever one it happens to be. Okay. So we want an equation that models this, and it says what the nth term is. So if we want the 50th one, we can find it. If we want the whatever, we can find it. And so here's, instead of writing y equals 2x plus 8, we write it this way. A sub n equals 2n plus 8. So we write it as a function. What's the name of this function? A. That's its name. Okay? And here we're finding the nth term. So if I want a sub 10, can we do it? Yeah. 2 times 10 plus 8? 28? Right? Okay. What if I want a sub 100? Can we do it? What is it? Yeah. So I told you what it was, didn't I? Well, guess how I did that? I didn't sit there and add them all up and 2 up 100 times and everything. I figured out the equation, right? I cheated. Is it cheating?
No. Yes.
Yeah, I don't think it's cheating. Okay. So this is the way we write a function that describes a series like this. Okay. So now, Augustine, stay awake, buddy. I beg to differ. Okay. So let's look at this next series. 12, 6, 0, dot, dot, dot. Okay. Can you guys tell me the next number in the series? Cooper? Negative 6. Could you tell me the next one? Negative 12. Next one? Okay. So now I have a big important question for you. Is this an arithmetic series?
Yes.
It is. Because what's happening every time?
Taking away 6.
We're actually adding something each time. What are we adding?
Negative 6.
Negative 6. That's kind of weird to say it that way. But an arithmetic series, you're adding the same amount each time. And in this case, we are adding a negative 6 each time. So what is the common difference? What is the slope?
Negative 6.
Okay. So the common difference, or the slope, is, I'm just going to erase that part, negative 6. Okay? So whenever you're adding something each time, even if you're adding a negative each time, that's an arithmetic series. Okay, so, okay, I want to graph this thing. Okay, I want to put it on a coordinate plane like this. Well, I can't just graph a 12, can I? Okay, so what's the other number that goes with this 12?
1.
A 1. X is 1, so the first term is 12. Okay, so that means when X is 1, Y is that a 12? That okay with you guys? Okay. When X is 2, 6, right? When X is 3, 0. When X is a 4, -6. And you guys are getting the idea, right? Okay. So can you guys kind of see the y-intercept? It's up there a ways, isn't it? We kind of need to know it. And I think we can figure it out. When X is 0, Y is?
18.
Yeah, 18. And so we always think of the term number as X and then the value in the series as the Y. So you always want to write your terms above. 1, 2, you know, this is term 1, term 2. But we always want to know that one, don't we? Because what is it?
The y-intercept.
Yeah, it's our y-intercept. So if we start with, well, we could say y equals mx plus b. Or we could say a sub n equals the common difference times n plus, I guess we're still going to call it b, the y-intercept. However you want to say it. In this case, a sub n equals, now what's the slope or the common difference? -6n plus 18. Okay? So, not only can we find the next one in the series, can I find the 10th one? -6 times 10? So, a sub 10, -60 plus 18. There you go. -42. Is that what you guys got? Yeah, you did that one. But you didn't do a sub 100, did you? Okay. Did you figure it out? -600 plus 18. I believe I said it was -582. Did I get it right?
Yeah.
Okay. Okay. So now, on that same paper that you were working these other two on, the bell work paper, let me give you a new series. We'll make it simple. I have some questions for you. Question 1: is this an arithmetic series?
Yes.
Okay. Question 2: what's the next one in the series?
20.
20. Okay. Question 3: what's the common difference?
5.
5. Okay. So the common difference or the slope is 5. My next question is, what's the y-intercept? What's the 0 term?
0.
It is 0. Okay. So can you guys write that equation?
Yeah.
And write it in that function way, a sub n. A sub n equals. Okay? A sub n equals 5 and you can say plus 0, that's fine. Okay, you don't have to, but for this case, just to be clear, we're going to say plus 0. And then, could you guys find a sub 10? What is it?
Yeah, that's 50.
It's 50. Yeah. Can you find a sub 100?
500.
Okay. So you can find the 100th term, you can find whatever term you want. So we've done a couple of things here. How do we find the next one? That's important, right? But then how do we find the nth term? How do we find any term that we want? That's important. Okay? So, Okay. Here we go. Online bidding for, what are we going to bid for?
Sword.
Puppy. Doesn't matter. Okay, here's the bid number. And here's the bid amount. You're going to go 4,000 right off the bat. That's kind of how puppies are going right now. But just to make life simple, can bid number 1 just be like 60 bucks? Is that okay?
Yeah.
Okay. 60 bucks. Bid number 2, 65. Bid number 3, can you already tell where I'm going with this?
Yeah.
Bid number 4, okay. So is this an arithmetic sequence?
Yes.
Okay, it is an arithmetic sequence. And the common difference, or the slope? 5. Okay. Now, realistic in this, is there ever a bid number 0?
No.
No. But we kind of need to pretend like there is. Is that okay?
Yes.
Okay. Now, sometimes there is a 0 does make sense. Okay, and I'll show you another one like that. But if we kind of backtracked a little bit, what would bid number 0 be? 55, right? So this equation, a sub n would equal 5n plus 55. And then we would know, okay, what's the 10th bit going to be? What's the 100th bit going to be? Something like that, right? Okay. So take a look at this one. I'll just do kind of the similar thing. At 1 minute, okay, let's say there's 3 inches of water. So this is the time. This is water in inches. This is time in minutes. Okay. Okay, so then 2 minutes, there's 8 inches of water. And then in 3 minutes,
15.
Nice. And 4 minutes, what's the common difference?
It's 5.
So every minute the water's coming up 5 inches. Okay, so that's our common difference, or our slope. Okay. Does it make sense in this case to think about time 0?
Yeah.
At time, I think it does. I think it makes sense to think about time 0. Okay. Is that a real thing that can actually happen? No, but it's fine. Okay. We can still say a sub n equals 5n minus 2. We can still do that. And that's still going to work and give us a model for this arithmetic sequence. Sometimes, I guess I could have made it so at time 0 there was 0. That could have been done, couldn't it? Okay. I don't think that would be too hard. All you have to do is say, well, you already know. Okay. How about this one? How about here's a series. So this is, again, water in gallons, let's say. And this is time, oops, in days. Day 1, 180. Day 2, I don't know, 160. Day 3, 140. Does it make sense to go back to day 0 in this case? It does. And how much was there at time 0?
200.
200. And what's the common difference?
20 minus 20.
Negative 20. Awesome. Good. Negative 20. And our initial amount? Right? So a sub n equals negative 20n
Plus 200.
plus 200. Why would I want this equation? What good would it do me?
Tell when you run out of water.
Yeah. When am I out? Right? When are we going to be down to 0. When is this number, when is a sub n going to be a 0? How can we find out when a sub n is going to be a 0?
Put a 0 in.
We put a, yeah. And gosh, that separates a good mathematician from a bad one. Bad ones would be like, well, we'll just keep going. No, if I want to know when a sub n is a 0, I put a 0 there. Right? Does that make sense? Negative 20n plus 200. Can you guys already see the answer? There you go. So, we know at 10 days we're going to have 0 gallons of water. Okay? So does that mean we die?
No.
No. It means at day 8, maybe we go get some more. Or maybe at day 7. Or maybe on day 9 we go get some more or something like that, right? Or maybe we just plan a trip on day 10 to go get some more, whatever it is, right? So if this is a diesel tank and it has 2,000 gallons in it or 20,000 gallons in it, and we're using 200 gallons or 2,000 gallons a day or whatever it is, when do I need to order more? How many days out? Well, that depends. How many days will it take to get it once I order it, right? Okay. So let's say you're working for Nielsen Construction and you've got this giant tank of diesel fuel and it's getting used up, right? Do you order more when you run out? Okay, so do you want the truck with the tank full of it to show up when you still have half a tank full? No, because if it shows up, if the big tanker shows up to fill you up, and you can only take half of what they have to fill this back up, doesn't it cost to have them come and deliver it and stuff? When do you want them to show up? Yeah, well, I don't think I'd want them to show up when I was empty, but
When you're close, though.
when you're close. But you got to gauge it, right? Okay, and you got to know, well, I got 4 days left and it takes them 3 days to deliver this. I got to order today. This is the day I've got to get it ordered, right? So it comes on Thursday before I run out on Friday. That way I get it delivered. I don't want to have them come and deliver it more often than I have to because it costs me money every time they show up, and I don't want to run out. Because what happens if I run out? What happens if it runs out and Nielsen's can't run any of their over-the-road trucks or any of their big equipment to move to make a road or whatever they're doing?
Delays a lot.
Do they have to send all the guys home?
Yeah.
Yeah. Do you have a job anymore? No. You don't get an F for Mr. Collard. You don't get a D or whatever. You get to not have a job. You get to sit home on the couch tomorrow. Okay? You cannot let that happen. All right? So, now just so you know again, not every series is arithmetic. And you guys don't know how to write them. If it looks like 3, 9, 27, 81, well, we can see a pattern here, but it's not adding every time, is it? Okay? So this is not an arithmetic series, and we cannot model it with this this model right here. So it looks different. Now, we can do it, and you're going to learn how to do it this year. Okay, but not yet. So make sure that you think about, is this an arithmetic series before you try to do this. And what if I just tell you this? What if I tell you the first term is 34 and the common difference is -3? Is that enough to write an equation?
Yes.
Yeah.
It is. Because a sub n equals,
34.
whoa. -3n, okay,
37. Oh, wait.
34.
plus 37.
Yeah.
Where the heck did 37 come from?
I added it.
Okay, so if this is term 1, we need to know what?
What term 0?
Right, we've got to put term 0, right? That makes sense, Peyton? That's tricky though, isn't it? But you have to remember that this is term 0, not term 1. Okay. You're ready.
Okay.